This is the solution set for vectors number 5. To begin, we draw our vectors as they would emerge from the origin. In this instance, we will use a scale of 1 block equaling 2 kilometers per hour. Thus, our ship is headed west, so we have a vector that is 15 kilometers per hour long heading towards the west, and then one headed towards the south that is 3 kilometers per hour. We then again redraw our first vector as it would emerge from the origin on the opposite side, and then from the tip of that draw our second vector, which is 3 kilometers per hour south. The resultant vector then goes from the origin to the tip of the last vector that we added. Again, to find the total or resultant velocity of the ship, we use the Pythagorean theorem, and we will again solve for the length of c, or the magnitude of c. By plugging in what we know and using a as 15 kilometers per hour and b as 3 kilometers per hour, we are able to solve to find the resultant velocity of the cruise ship of being 15.297 kilometers per hour. Question number 2. Question number 2 uses a scale of 1 block equaling 500 newtons. We again have a force pulling towards the west of 3,000 newtons and a force pulling towards the south of 2,500 newtons. The first step is to draw them both as they emerge from the origin. After that, we redraw vector number 1 as it emerges from the origin. We then follow by drawing from the tip of vector number 1, vector number 2 coming towards the south. In this instance, I drew it from the origin, and then I'm going to pick it up and slide it over to the tip of V1. We again draw the resultant vector from the origin out towards the tip of the last vector that was drawn. So from the tail of the first to the tip of the last. Again, to find the magnitude of the resultant vector, right, the length of it, we use what is known as the Pythagorean theorem. Again, a squared plus b squared equals c squared. Here you'll see that we just have c is equal to the square root of a squared plus b squared. We're able to plug in our information here. So we have the square root of 3,000 newtons squared plus 2,500 newtons squared. And once we've squared and added those two together, and then taken the square root of that, we will end with a final force acting on the boulder of 3,905.12 newtons. There are two questions here in question number 2, and the second is to find the acceleration of the boulder if it has a mass of 1,000 kilograms. For this, we'll use Newton's second law, which is just represented as sigma F is equal to m times a. Well, we have found the sum of the two forces acting on the boulder. It was a vector sum, so we needed to use the Pythagorean theorem. Well, to find the acceleration of the boulder, we will just take sigma F divided by m. So we have 3,905.12 newtons divided by 1,000 kilograms is equal to 3.91 meters per second squared as our acceleration. Question number 3. Question number 3 is relatively basic, and in question 3 we're able to use a scale of 1 block is equal to 1 newton. Vector A is a 5 newton vector towards the north, and vector B is a 10 newton vector towards the east. Again, we follow the very same steps. We begin by drawing our vectors as they emerge from the origin, and then we redraw them in a tip-to-tail method. So, again, we draw our first vector, which is our 5 newton vector towards the north, and then from the tip of that we add our 10 newton vector to the east. Remember, the resultant vector always goes from the origin to the tip of the last vector. Again, to find the magnitude of that vector, we use the Pythagorean theorem. Again, arranged to find the magnitude of the resultant is just the square root of a squared plus b squared. So we plug in our 5 newtons, square that, and add it to our 10 newtons, which we are then also squaring, which will give us the square root of 125 newtons squared. Taking the square root of that will leave us with 11.18 newtons. Question number 4 is the most complex vector addition question on this sheet. To solve this, we use a scale of 1 block is equal to 50 meters. It is the most complicated because it gives us the resultant vector and asks us to find the position of the man prior to him making his stop. So the first piece that we draw is the resultant vector, which is 360 meters exactly north. And we know that to get to that point, the hiker had to walk exactly west 260 meters. So what we're asked to find is where along their path were they before they turned left to make it back to the point where they were directly north of their starting point. And to do that, all we do is connect our two vectors, and we go from the origin to the tail of our second vector that was headed directly west. This gives us the first leg of our hiker's trip. To find that and to find the length of that, we again use the Pythagorean theorem. We know the two legs of this triangle. We know that first is the 260 meters that they traveled west, and the second is the 360 meters north of where they started. Plugging that in, we are able to then solve for the resultant vector, or I should say the first part of our hiker's trip, which has a distance of 444.07 meters. Again, please post your questions on the class website.